Hello, everyone, and welcome to another wonderful day of chemistry. So today we get to talk about that wonderful topic of dilutions, where we essentially take something that's concentrated and, well, mix it up. And it is worth noting, this is one of those topics that really does kind of enter your daily life. And most of the time, this is when I'm trying to make a solution. This can be a cleaning solution or it can be a chemical reactant solution. And I want to have a known concentration of that solution, but I don't want to make it from solid. So what I often do is I take a concentrate and I dilute it with whatever the solvent I'm using, usually water. And the key idea of this approach is that the moles of solute don't change when I add solvent. So moles in equals moles out. And since the moles are staying the same, the only thing that we're going to see changing is the volume. But since molarity is moles over volume, this does end up with a lower concentration or lower molarity. And this leads to a classic idea of there's an inverse relationship in between volume and molarity. If I increase volume, molarity goes down. If I decrease volume, then molarity goes up as I'm concentrating the system. And we can also express this mathematically by taking this idea that the moles of solute don't change. So again, I'm taking a small bit of a concentrated system, increasing the volume, but keeping the moles constant, which should end up with a lower concentration. And so what we can do is saying that molarity times volume should be the moles of the solute that I originally add as part of what we call an aliquot. And the moles of solute that I remove from my original solution should also be the moles of solute in my final solution. And again, molarity times volume, both of these will equal the solute, whether it's initial or final. This is more commonly known as M1V1 equals M2V2. But again, when in doubt, go ahead and write out the full units. Moles over volume times volume equals moles over volume times volume. And it is worth noting that this relationship can hold for any sort of unit of concentration. And we'll play with several of these various units as we go through the rest of the year. So whether or not we're talking about parts per million, molarity, molality, anything we use, you can go ahead and use this general form. However, one of the things that you should make note of is always be sure that your units will cancel out. So indeed, it's actually even possible to use milliliters instead of liters for your volumes, as long as both your initial and final volume share the same units. So let's go ahead and kind of put this idea into practice. So here's kind of a fun one. You can have hydrogen peroxide, which is used for hair dyeing. The reason why they have the phrase peroxide blonde is it's a way to bleach out your hair, remove the color. And the hydrogen peroxide for hair dyeing is about 10%. Again, this is mass of hydrogen peroxide per volume solution. This ends up being about a 3 molar solution. Now, if I'm going to want to go ahead and use that hydrogen peroxide for cleaning wounds, I need a 3% solution, which is about 0.66 molar. Now, I want to know exactly how much water will I need to dilute 100 milliliters of my hair dyeing solution so that it's usable for wound cleaning. So in order to do this, I'm going to set up M1V1 equals M2V2. Now, the question is, what do I need to know? So I know my original concentration, that's an M1. I know my initial original volume, that's my V1. I know my final concentration I want, M2. So what I'm looking for is my V2, that final volume. So I go ahead and rearrange the equation to solve for my final volume, input my other variables, and it turns out I need a final volume of about 460 milliliters. Again, watching out for sig figs, but always carry a couple of extra digits for the calculation. However, I didn't ask for the final volume. I want to know how much water I need to dilute this solution. So if I start with 100 milliliters of my original solution, and my final solution has to be about 460 milliliters, I need to add enough water to make up the difference. So the water being added will be the difference in this final, in between the final uh, wound cleaning solution and my original hair dyeing solution. So we go ahead and take the difference, and it turns out we need about 360 milliliters of water. So this is the major idea when dealing with dilutions. Watch out for your units. Otherwise, M1V1, M2V2 will take you a long ways. So next time, we're going to be using this idea of solution concentrations to apply to stoichiometry. Until then, take care.